Hi, everyone. In last lecture, I demonstrated how to estimate pool model in R. So here is the continuation. So we want to demonstrate how to conduct or how to estimate fixed effect model in R. So there are two estimators to estimate fixed effect model. We can either use what we call within estimator, or what we call least square domain variable estimator. Okay, the result of both are identical. Anyway, the result of both are identical. So to do that, so we have already imported the data. I'll just continue, and I've already set my data as panel. Okay, now here is the function I'm going to use. I'm going to PLM, just like we did under pool and pool model. The only thing that changes is that I'm going to set model to within instead of pooling. So if I run this line of code to help me to estimate that, you can say I'm able to estimate fixed effect model using within estimator. So to see the result, I will just use summary function. So use it here. You can see here's my result. Okay. You can see here's my result. You can see this p-value indicate that the estimate are significant, even at 1%. You can see that if that 1% increase in value, in market value, we lead to about 0.59% increase in investment. And we also have, if there's 1% increase in capital stock, and that will lead to about 0.26% increase in investment. And you can see, like I said before, the estimate are significant based on p-value. Okay, based on p-value. You can see. Now, let's say I want to extract fixed effect across cross sections. I want to have differential intercept for each of the cross sections. So I will just use this. I will just use this function. Fix. Run this. I have that. So let me run it. You can see here. You can see. You can see. I said D first. Okay, meaning that I want you to suppress the first one. This one will tell me how compare each of these firms, okay, is to the first firm. For example, they are not interested in fixed effects. Okay, we are not interested in fixed effect interpretation. We are only interested in the question of the regressors. Okay, now let's use LSD V estimator to estimate fixed effect model. Okay, so what this one is in, instead of using this function to generate our fixed effect, that is differential intercept for each of the cross section, we can actually add this plus factor, and we put firm in bracket. That is our cross section, the name of the cross section. You can see data set equal to this panel setting. Okay, and I will simply use LM function, R-based function. Okay, so if I run this, so I'm going to then let me see the result by running this summary function. Okay, you can see I have this. You can see the result. I have the same result I had when you can see you have the equation for the intercept, you have for the value, you have for the, you can see for the first firm, you can see 0.199. See the same thing we had when we actually use this function to generate our differential intercept. You can see it's the same thing we had. You can see that is the same thing. Okay, so you interpret the same way. So the only difference between this one and this one is the only difference between using LSDV is that that will allow us to have our estimation, okay, at once. We are going to have our estimate at once, the same result, okay? But here we need to generate it. That's the only difference between the two. Like I said, in most cases, we are not interested in fixed and differential intercept. We are only interested in the coefficient of the regressors. Okay. Now, for diagnosis test, so I will carry out the same test. So serial correlation test, I will use usual BPG test. Then of order 2, you can see I want to test for order 2. So I also have so let me test for serial correlation test. If I run this code and the line of code in 48, okay. So for heteroscedasticity, if I run this, there's also heteroscedasticity. You can see I'm going to put value. Okay. So with that, I can also use what I call robust covariant matrix estimator for fixed effect model. You can see the line of code and description there. You can go through it. Then just go through it